start here. That's my correction. Before I make a z-score, I correct, not 11, I make it 10.5. Because it's not normal. How the hell? It's not continuous. I got to correct for the fact it's not continuous. And we saw over there, if I forget to do it, my answer is way off of what it's supposed to be. So now I make a z-score out of 10.5. 10.5 minus 9.6 divided by 2.972. It's like 0.27. Bless you. Support it. 0.3028. 0.30. And now you just look that up like always, right? I want the area above, so when I look that up, I'm going to get this area, of course, right? So when I look up 0.30, what area do you get? 0.6179. 1 minus that? Yeah. .3821 I get for the upper part. Now I can check this very easily. I can check it using that binomial CDF, right? Because I want to get a cumulative part. I don't care about a single piece. I need to get a whole piece. So if I do, so to check this, let me put it over here. To check that real quick, I do binomial CDF NPX. So 120.08, right? And then I want to go up to what? I want greater or equal to 11. The opposite of that would be lower than 11, which would be 10 or less, right? So I want to go from 0 up to 10. And if I do 1 minus that, I'll get the other side, right? Just like I had to do 1 minus this to get the other side. Yes, sir?
It wouldn't equal 11 since it's equal to or less?
How do you mean? What do you mean?
If you flip it, wouldn't it be equal?
No, this is greater or equal to 11. What's that leave out? 10, 9, 8. This includes 11. The opposite won't include 11 then. It includes everything this leaves out, up to 10. So if you do that, oh, shoot. My calculator is currently videotaping this. So somebody got it? What do you get?
Wait, so the 10 is because it goes, it's saying anything greater than 11. I mean, less.
Binomial CDF always goes from 0 up to the number you plug in.
Okay.
Always. So if I actually want from something above that, if I want 11 and up, I have to do 1 minus the opposite, which is 10 and down. So if I want 11 and up, what am I leaving out? 10 and below, right? From 0 up to 10, I'm leaving out. So if I do from 0 to 10, 1 minus that should be exactly what I want. And what do you guys get when you do that? Have I told you where binomial CDF is? It's on your Bible, on your calculator Bible, right? If I'm you, I am sure as all hell following that thing along so I know how to check myself whenever we hit a new section. But this bad boy is above VARS. You see that VARS button, which is right below your... yeah, it's above there. It's called DIST for distributions. So if you hit second, variables VARS, you'll get into the distributions. And if you scroll down, I can't remember which one it is, but binomial CDF. Okay. Binomial CDF. I don't know which letter or number it is. I can't remember.
Oh,
369? 365, and the answer was 3821 that we got here, so that's not too far off, right? Okay, maybe. So your answer for the approximation obviously is never going to be exactly right because it's an approximation. It's an approximation we're making. But that's what I mean when I say nav. So I just draw that box, and all you got to do is figure out which side do I want to do. I never change 11 into a z-score. I have to move it up or down by 0.5 and change that into a z-score. And I'm just trying to pretend like it's continuous, not discrete. That's really the only reason for that. The big thing I want you to get out of this section, I can actually deal with you not understanding how the hell to do this work. The big thing I want you to get out of here that we're going to use much more often is going to be this. How do I check a binomial situation if it's normal enough to do stuff with it? That's what we're definitely going to use a lot of. Okay. Yeah.
When you're doing that check and you enter that in your calculator, do you have to do 1 minus first, or do you?
You could do this and then just do 1 minus answer. I mean, it doesn't matter. As long as you do 1 minus what you get,
So
you're
like
fine.
with our ending result, then what is that the answer to?
What was the answer? What we get as the approximation? 0.3821. What do you get when you do it as a binomial? All right.
Okay.
So they're decently close, right? It's not going to be perfect. Yeah.
So on a quiz or an exam, when we're checking it, do you want us to do it the long way for each individual value? Or would you,
How do you mean?
like if you're doing,
I'll tell you this. When I want you to do this process, I will actually be really nice, like I was in the practice test. I'll say use the nav. And that's when you say, okay, nav means draw that box, figure out which side to go from, make a z-score out of that 0.5 adjusted number. So when you see the nav, I'm being very nice, right? I used to be more evil with that. I used to say, here, figure out this kind of probability. You have to identify it as a normal approximation problem. But I'm getting soft. You guys probably wouldn't agree with that too much. Okay, so any other questions on that? And again, so far we've got 2 tweaks to the normal z-score thing. A normal z-score is I give you a raw score next, like a IQ score or shoe size. You make it into a z-score, and then you look up the area. Right? That's a normal z-score problem. The first tweak was, if I take a sample and ask you about the sample mean, we have to change the standard deviation, and then all the steps are the same. The second tweak is, if I have an NPQ problem, and I'm trying to use an approximation using a normal distribution, I have to change the number they give me by a half, and then all the steps are the same, right? Change it by half, and then z-score, look up the area, make sure it's the right side, I'm done. So each tweak is just one tweak in the whole process. Everything else is the same. The big problem, of course, as always, is when the hell do I do what, right? Yeah. So we are going to get just a little bit into chapter 7, a little bit. Aw. Tens are dying. So can somebody remind me what this formula is? What is it for? Okay, to get to a data point, 11, right? So if I want some specific data point, I can start at the mean and go this many steps to get there. I just have to know how many steps away it is. How we doing? I mean, that hopefully should be pretty straightforward. And like I told you, I'm going to ask you every single test what the hell a z-score is. And this formula will now be on your formula sheet, and it is the definition of z-score if you're able to read this. This many steps from the mean to get to a data point. Bam. That's what a z-score is. What would I put here if I didn't know the real mean? If I don't know the real average age at Grossmont, what could I do to get a feel for what it might be? What could I do if I don't know the real average gas price right now? Besides going under your bed and walking everywhere. hiding or just walking. How do I estimate it? How do I get a? I don't want a data point. Now I'm getting sad. So if there's something we don't know anything about, like we don't know the average income of people in San Diego.
Take a sample.
Take a sample, thank you. No, Brian. You put that answer away and you never take it back out. So if I take a sample to get a feel for this, I couldn't put mu there. What could I put there though? If I take a sample, I could put what there? What can I get from the sample? I can get the sample
Your
average, which is what? The symbol. What's the symbol for the sample average? X bar. Okay. Somebody back waving at me. All right. So, a little review, I guess. Mu is the what mean? Population. When I can't get a hold of the entire population, which is almost all the time, we instead take a sample and find the sample mean, right? Okay, cool. Now, later we're going to worry about what happens here, but I'm going to assume that I know the actual standard deviation. Now, tell me this. Who knows what happens here? What did we do to get x bar? What did we have to do to get x bar? We had to take a sample. So we took a sample of n things. Right? What has to happen when I'm talking about the sample means and I've taken a sample of n things? What must change? Standard deviation. So this has got to become that. So that's my formula now, right? So really chapter 7, and I'm kind of talking about section 7.3. I can't remember if I turned it around to be 7.3 and then 7.2 on the homework, but I'm going to do 7.3 first. Because it comes right off of this formula that we already know. So tell me this, if I wanted to be, let's do a problem. Let's say we do take a sample of let's say 80 people and find an average income, and this is really, I got nothing here, of let's make it, yeah, $41,980. Right, so we took an average, we took a sample of 80 people from San Diego. Hopefully it's a random sample. We got to assume it is. So take a random sample of 80 people from San Diego. We find an average income of this. And we know that the standard deviation for everybody in San Diego is, what makes sense to your job? $8,122. Right now I'm just validating what Brian said earlier, but I don't have time to go get 80 people right now, so let's just go with it. I want to be able to tell somebody, if I tell somebody the average for everybody in San Diego was $41,980, am I being honest?
No.
Of course not, because that came from a freaking sample. I want to give somebody a feel for what I think the real average is based on my findings. So I could tell somebody, I think it's close to $41,980. What's wrong in statistics with saying, I think it's close to this? What is close?